Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, or DTC B12C5, indicates an engine start-stop switch failure, specifically for the 2011 to 2017 Honda Odyssey. This issue may prevent the vehicle from starting or stopping the engine properly. The engine start-stop switch is crucial, as it is the primary interface for the driver to both start the engine and turn it off. It is located on the dashboard at the center console, usually near the gear shift, making it easily accessible for the driver. If this switch fails, it could lead to potential operational issues, insecure engine starting, or unintended engine shutdown. Diagnosing this failure requires a systematic approach to isolate whether the switch itself is at fault or if there is an underlying electrical issue, as detailed in the proper diagnostic procedures. The engine start-stop switch is integral to vehicle operation, enabling drivers to start and stop the engine seamlessly. This component is located on the vehicle's dashboard, typically near the gear shift for easy access. Its function is not merely to start the engine, but also to signal the vehicle's electrical systems to engage or disengage based on user commands. When failure occurs, the system may not respond to user input, thus signaling a malfunction. This DTC code indicates that the switch may no longer be sending the correct signals, which necessitates immediate attention. Failure of this switch can lead to starting difficulties or even unintended engine shutdown, which can pose safety risks while the vehicle is in motion. The first potential cause to consider is a faulty engine start/stop switch, which can happen due to wear or internal failure. Following this, it is critical to examine electrical connections for issues such as poor connectivity, frayed wires, or deposits that could impede electrical flow. Sometimes, problems may not stem from the switch itself, but rather from open circuits or high resistance within the wiring that connects the switch to the control units. Each of these causes requires a systematic testing strategy to isolate the fault effectively. Addressing these potential issues promptly can prevent further complications and ensure that the vehicle operates smoothly and reliably. Symptoms associated with DTC B12C5 include a complete failure to start the engine, indicating a direct issue with the engine start-stop switch. In some cases, users might experience intermittent engine shutdowns, which can be disconcerting and alarming while driving. Another common symptom is a lack of response from the engine start-stop switch when pressed, which indicates that the switch may not be relaying the essential start signal. These symptoms not only affect the user experience, but can also pose safety risks if not addressed quickly. Identifying these symptoms promptly can help in managing service appointments and potential breakdowns effectively. The first troubleshooting step involves clearing the diagnostic trouble codes using the Honda Diagnostic System, commonly referred to as HDS. This diagnostic tool allows technicians to reset any stored codes that may affect the troubleshooting process. Clearing DTCs can help in identifying whether the issue is intermittent or persistent. By removing old codes, technicians can focus solely on current issues during subsequent tests. Ensuring your HDS is functioning properly is essential, as accurate clearance will facilitate precise diagnosis moving forward. In the second step, technicians are instructed to press the engine start-stop button at least 20 times, and then wait for a minimum of 20 seconds before proceeding. This process can help reset any temporary glitches in the system, enabling the unit to recalibrate. The act of pressing the button multiple times may vary the electrical signals sent through the system, potentially revealing intermittent issues that were not present during initial inspections. After the wait, it is crucial to check for any repeating DTCs, which helps to confirm whether the same code, B12C5, persists. Following the previous steps, the next crucial action is to recheck for DTCs using the HDS. This step helps technicians determine if the previous actions resolved the issue, or if DTC B12C5 still indicates a problem. If the code reappears, this suggests there is a persistent issue with the engine start-stop switch or associated components. A yes answer leads to further diagnostic steps, focusing directly on the switch itself. Conversely, if the code does not reappear, it could indicate an intermittent error, warranting further investigation of connections and wiring rather than component replacement. The fourth step involves conducting a direct test of the engine start-stop switch to ascertain its operational status. This testing verifies whether the switch is functioning correctly and sending the appropriate signals to the vehicle's systems. Should the test indicate that the switch is faulty, then technicians must proceed to replace it to restore normal functionality. The precise nature of the test will include checking the electronic signals that are emitted from the switch during operation. Accurate analysis of switch performance is critical in this phase of diagnosis for proper resolution of DTC B12C5. Step 5 instructs technicians to ensure the engine start-stop switch's 10P connector is securely reconnected. This is critical, since even the slightest disconnection can lead to issues in switch operation and reliability. Thoroughly inspect the connections to ensure no pins are bent or corroded, as these can obstruct signal transmission. This step is intended to reinforce the reliability of the electrical connection. A well-secured connection ensures that the electrical signals are effectively transmitted to the system without interruption. After reconnection, moving on to the voltage measurement phase is essential for diagnosing potential wiring issues. In this sixth troubleshooting step, technicians must measure the voltage between the body ground and the engine start-stop switch, 10P connector at terminal number 5. This check is vital for confirming whether battery voltage is indeed reaching the switch. If the voltage is present, it indicates that the wiring and connectors are functioning correctly to that point. However, if the voltage is absent, it typically points toward an open circuit or high resistance within the wiring. Repairing any found issues with these connections is essential to restoring the switch's operational integrity. This voltage testing ensures that the electrical supply is consistent, signaling that the system is potentially in order up to that juncture. The seventh step directs technicians to press and hold the engine start-stop button. This action must be accompanied by checking for continuity between the keyless access control unit connector B, specifically terminal number 25, and the engine start-stop switch 10P connector, terminal number 2. This test assesses whether the signals from the switch are effectively communicating with the control unit. A successful continuity test indicates that electrical signals are being transmitted properly, signifying system integrity. If continuity is inadequate or absent, this indicates that there could be a wiring fault or issue within the switch, warranting further inspection or replacement. Hence, testing for continuity is paramount for determining effective communication in the vehicle's electronic system. After completing the necessary repairs, a final verification of the entire system is imperative. Technicians need to check whether the engine operates as intended with the switchover and ensures all features tied to the engine start-stop switch are fully functional. It's critical to confirm that no additional diagnostic trouble codes or DTCs are present post-repair, assuring the integrity of the system is restored. A complete operational check can reveal any lingering issues. This verification phase ensures that the original problem has been rectified, providing peace of mind to the vehicle owner. It's essential to document all findings and repairs for future reference and potential troubleshooting. Preventive maintenance is crucial in ensuring long-term reliability of the engine start-stop switch and associated systems. Regular inspections can help catch potential issues before they escalate into more significant problems. It's advisable to check electrical connections periodically, ensuring they are free from corrosion and dirt, as these can impede signal strength. Cleaning connections can prevent failures related to poor contact. Routine visual checks can also aid in detecting wear or aging of components, prompting early intervention. Establishing a preventive schedule ensures that the vehicle remains reliable and minimizes the chance of unexpected breakdowns associated with the starting system. In conclusion, effectively diagnosing and resolving the DTC B12C5, which indicates an engine start-stop switch failure in the Honda Odyssey from 2011 to 2017, requires a systematic approach. It is essential to confirm whether the switch itself is faulty or if there are electrical issues preventing successful operation. Going through the necessary troubleshooting steps ensures that every aspect of the starting system is verified and any faults are corrected. Furthermore, maintaining consistent preventive care will significantly enhance the vehicle's operational reliability. Being proactive not only extends the lifespan of components, but also builds confidence in vehicle performance, ensuring safe and dependable journeys for all passengers. Please like and subscribe to the channel. See you next time.